I'm going to go through a few things. I'm going to talk about kind of OpenRank and graph algorithms and scores in general. And then I'm going to walk through this Python notebook that I also covered in this article and a few other places that walks through the steps required to create an OpenRank graph and use it in a feed. And then I'll also cover some of the underlying queries that power this graph. Cool. So before I get into it, this guide, it's just on my my Crypto Data Bytes blog, and there's a few resources that I've linked at the end of the guide here, where if you just want to skip to reading about this yourself, you can go read the documentation, take a look at the official OpenRank SDK, take a look at the notebook, and take a look at the kind of dashboard I've created for output feed, if you prefer to go through things yourself. Let's walk through things step by step. In crypto, essentially what on most applications, just a naive leaderboard in terms of if you go to pump.fun, if you went to like maybe even if I go to like Zora.co, NFT mints, they have more of a, they've actually upgraded to a follow feed. But yeah, for the longest time, this is how our feed in crypto look. It's just some sort of leaderboard that's, this NFT had 20,000 mints in 24 hours, so it should be at the top. Or if I go to, obviously, Uniswap is a little different, but there's so many sites that are like just sorted based off of like the yield or the liquidity or the volume, where it's basically just a very simple feed. And I think this works well when you have very small communities or user bases like we do in crypto, where it's like maybe 20 to 30,000 people realistically, if that. But as we scale to the hundreds of thousands or millions of people, this kind of basic leaderboard doesn't work, right? Because if you went to Instagram or TikTok and they just had, here are your top viewed, those apps would not be as addicting or popular as they are today. So there's a question around how do you get to a more personalized feed that we're starting to see applications experiment with. I'm not logged into Zora, but Warpcast, for example, which is built on top of Farcaster, which is like a Twitter style app. They have a feed that's a little smarter. It's not just completely based off of likes in the last X amount. Right. So for these kinds of feeds, a lot of them, for example, for Twitter, they have a fairly complex like machine learning plus graph algorithm repo. So Twitter has the algorithm repo, and there's nice things here where you can see there's pre-processing of data for Twitter data, like tweet data, user actions, which would be like likes or not recast. What is it called again? I've forgotten the Twitter name for it. Tweet, and just other kind of, profile visits, clicking into tweet, etc. And then they have models, community detection, graph embeddings, and then like they have PageRank in here. And they also have probably machine learning algorithms for detecting negative content or predicting kind of like, what's it called? Basically, supervised machine learning for predicting who might interact. And then they likely have some post-processing as afterwards. Here. Once you get that graph data, ML tag data, you put it through a deep learning network. And don't worry if none of this makes sense. I'm just sharing. This is how much more complex Web 2 gets than the leaderboards we're used to in Web 3. It goes through some deep learning, and then finally it comes out, and there's this kind of this filtering layer on top, which is you don't just output the model outputs onto a feed. You'll do some kind of processing based off of the kinds of product surfaces you have and the kinds of experiences you want to serve. And that's where they add on timeline versus trending versus following versus ads. That's mixed in at the feed layer, right? High level Web 2 style, you have this feature data that you get cleaned up. You use a bunch of different graph models or ML models or just human tagging, plug it into a deep learning model, which we're not going to get into a deep learning, and then you mix the outputs into feeds. So crypto, we're starting with we have some base data and we put it in a leaderboard. We have a lot to build out before we get to a stronger feed. And one of our beliefs, especially with OpenRank and the Karma 3 team, is very much that the graph algorithm side, the graph dataset side, is going to be incredibly important. This is not to say you won't use any machine learning. If you're trying to detect bots, for example, like botcast on Warpcast, sure, an ML model probably works better because you can just detect the text used in a feed or like the pattern, semantic pattern of words in a cast and see if that is like spam or not. But otherwise, a lot of crypto operates through graph algorithms. What do I mean by that? Right? What are the so-called graphs I'm talking about here? So in the Twitter example, your graph data would be like person 1 is liking person 2's tweet, where person 2's tweet is a quote tweet of person 3's tweet, et cetera, et cetera. There's this like directed graph, like this arrow graph that ties these users together, where the users are tied together by certain actions, which are called edges, right? So think of users as nodes, actions as edges. So in the crypto landscape, we have transactions and we have addresses, right? So there are many different addresses, and every transaction contains interlayered action, right? So one of the biggest differences between Web 2 and Web 3 is the fact that if you're building a Web 2 app like Twitter, there's only 3 ways to really interact. You're either liking, you're quoting or retweeting, or you're replying. No one else can add another action on top. Twitter itself does not really add actions. Web 2 is really built off of this, like you get 1 or 2 ways of interacting, and then they have a model and app that really optimizes those 1 or 2 ways of interacting. So graph algorithms are important, but they're not like the context they capture is fairly limited, or it's not limited, scoped, because the number of actions being added is very, well, it doesn't change. In crypto, every transaction could have 10 or 20 different actions inside of it, whether that's a transfer, a mint, a delegate, a vote, an LP provision, an airdrop, et cetera, et cetera. There could be many different actions. Every single year, protocols invent new interactions. While the addresses themselves are standard between apps, which is nice, the interactions between addresses get extremely complex, and that context is built up over many transactions. So that means that for something as simple as us building, for example, a Zora mint feed for NFTs, there's a ton of different data we could use. It's not just that we're limited to the mint data on Zora. We could use OpenSea trading data. We could use NFT creator data. We can even just use P2P, like token transfer data, to kind of power the graph. And so while that means that we can ultimately create better feeds in crypto, that also means that there's a lot more work that has to go into it. So anyone who's been using Dune for a while probably loves that they can just, if there's some new trend that's happening, they can find someone else's work and just start from there. They don't have to build everything themselves. Dune is a community data platform because everyone is working together to put together this infinitely growing context on many different blockchains. Graph algorithms are probably going to be the same way. It's not just going to be Twitter with their own kind of closed source, or open source to here, but closed in the sense of no one else can add to it and no one else can really borrow from it. If you use Twitter's feed to try and power Instagram, like it wouldn't work or make sense at all. But in crypto, that actually would make sense to be able to use other people's feeds, data, and graph data sets. So this takes a lot of people to work together. And when I say people, that's people like you guys, experimenting and learning how to build these graph data sets, plug them into different graph algorithms, and then mix those outputs of the algorithms and put them into different feeds, right? Again, preparing data, putting it through an algorithm, preparing feeds. Those are the 3 main steps. Hear me say that over and over again, because those are really the 3 steps you want to hammer into your brain. That's enough background setting. Let's get technical. So graph algorithms are very interesting. There's many different ways of analyzing the nodes and edges on a graph. One of my favorite places to go look at this is NetworkX. So NetworkX is actually a Python package specifically used for analyzing and visualizing graph data sets in Python. And you'll see there's a bunch of different functions here for calculating stuff like degree or density, or there's like number of connected edges. There's stuff like least, like path weighting. There's all sorts of here. Where do I find? Oh, wait, algorithm. There's all sorts of algorithms here as well for like connectivity, clustering, like stuff like clustering is like the LinkedIn's first degree, second degree, third degree connections. Like a lot of that is just based off of clustering. Neighbors, centrality is probably a big one that you'll hear in the graph space, whether that's like community grouping, clustering. PageRank is probably somewhere in here. PageRank is in here as well. So Network X, if you were just to scroll this page, you would be like, oh, okay, this is how deep the graph algorithm set of functions goes. OpenRank is a platform where they are basically helping you manage algorithms and outputs. The first one that they've really focused on here is an Eigentrust algorithm. So for people who know PageRank is basically you have 10,000 links and you want to be able to rank these links by importance and relevance. So you'll look at, for every single link, how much does each one link to other links in the list. And you can essentially start running an algorithm and see which links get backlinked to the most and use that to say which links should appear at the top of search. And this is what Google uses, or this is what Google started with. Obviously, Google's search is a lot more complex now. Eigentrust is instead an approach where you are wanting to rank the relationship of trust between peers. So instead of just saying, hey, this article linked to another article, in this case, we're looking at usually peers in the network. A good example here is actually something like Filecoin, where you want to be able to say, hey, how much do I trust this other node to be saving their files or sharing their files that are non-monogamic? So you could start using something like Eigentrust to weight between this file sharing network and have a factor of trust based off of files sent to each other per se, and use that to say, oh, for this network of Filecoin, like file sharers, which one of these is most trusted? Essentially, the OpenRank algorithm here has two parts. It's going to be your local trust is your main measurement of interaction, and your pre-trust is you want to select the people who you think are most relevant to whatever kind of feed you're generating and use that to weight their trust in the network, right? If you were looking at all NFT trades and you wanted to recommend NFTs to trade, you might choose a pre-trust that's specifically like the largest holders or minters of art blocks NFTs, so that your feed, ultimately your output is going to be all of the traders that are closer to the art blocks minter network. And then as a result, when you use that ranking, you'll see that your feed is more tailored towards, oh, this is a feed of recommended NFTs based off of the whole network and related network of art blocks NFT minters, right? You could put in a single seed, which is just you, if you wanted to get the recommended NFT trades of your network specifically, maybe one hop away from you, and then maybe 2 hops away from them, basically, is one way you can think about it. And this is all managed by C, which is, it's set to 0.5 as a default. The lower you set it, the more the pre-trust doesn't matter. The higher you set it, the more the pre-trust does matter. If you set it to 1, you're basically just seeing, hey, I just want to see what this seed is working on, and that's all that matters. So that still might be too theoretical. Let's just walk through the actual notebook that I've built. So the goal here was that I wanted to create like a ranked trending contracts feed based off of the top casters in the base channel, right? So I could have just done this by saying, hey, get me the top casters. So in this case, I'm looking at the base channel, all people that have casted in the base channel on Farcaster, and ranking them by engagement, which is how many replies and likes and whatever recast that they got on their casts in that channel. I could just take this engagement and then basically do a weighted average of the contracts that they're interacting with. But that's only the interactions of, I don't know. In this case, this was, I already put in, they had to have some sort of minimum engagement. The actions is maybe like 4,000 of these casters. Realistically, we're only going to choose 100 or 1,000 from the seed. But the base channel has, I think it's over 60 or 70,000 casters. So if I just used this like 2,000 to 3,000 people list to rank their actions on chain, that probably is going to end up being a lot less rich of a feed than if I'm able to somehow include all 60,000 casters in the channel, right? And you could just say, hey, just rank all of them and do that. But again, if you just rank them raw like this and then use it in ranking of a feed, I'm basically just going to get whatever these 3 people are doing recommended, because again, basically all networks, it doesn't matter if it's a social network, if it's a voting governance network, if it's like a NFT like Zora creator network, everything follows a power law, right? And we don't want this power law to be like the only thing that dictates our feed. So hopefully that gives you an idea of what we want to get to in terms of this trending contracts feed that takes into account the base channel casters, but uses the actions of basically all casters in the base channel. And you might be wondering, hey, Andrew, why did you scope this to just the base channel? It's partially because I want my graph to be smaller. 1, so that it's also more useful. But 2, when I say more useful, it's scoped to a context that matters. Scoping contracts to people in the base channel matters for putting the feed into a base channel app versus me doing a recommendation of all contracts based off of all addresses. That feed is probably very much just a leaderboard and doesn't tell us much. Checking, people can still hear me? Yes, okay, I think so. I see my voice is still going here. Yeah, so with that in mind, let's talk through how I put together my graph. First, I ranked all of the FIDs, the user IDs within the base channel, and you can just look at this query here for how I summed engagement. I wanted to make sure that I was taking the engagement of casters who had on-chain interactions, right? Because if you're actively casting, but you don't interact on chain at all, then you're really not going to be helpful for my graph data set here. So even if you're getting a lot of engagement, I don't want to include you in this feed, in this pre-trust, because you're just going to throw things off. So I ranked by engagement, required them to have at least 10 casts, and required that they're verified wallets, so the wallets connected to those Farcaster user IDs, I require them to have at least 50 transactions for them to qualify for the pre-trust. Ultimately, I end up with 4,280 users. Again, we're not going to use all 4,000 of them. That's just where I'm starting with in terms of next, I want local trust, which is like how am I connecting the nodes and relationships of the base channel casters. So I could have used like how much they're liking or replying to each other, but I wanted to use an on-chain metric instead because, again, we're recommending on-chain contracts. So their on-chain relationships matter more than their Farcaster social relationships in this case. You could actually try this with like the Farcaster likes and replies as the edges instead of the token transfers. And actually, you can subjectively go and check if that's a better graph or not. And I'm going to talk about better graphs, quote unquote, in a second. But for local trust, I just did transfers of, I believe, USDC, USDT, USDE, as well as ETH on Ethereum mainnet, Optimism, and Base for this. It says 107,000 rows, but I think it's 60,000 unique FIDs in this case. All right, so I take this and I just sum the US dollar value that they've transferred to each other. So like some of these people have transferred 1.5 million USDC to each, like dollar value to each other. They're probably really close friends or even just related wallets. That is how I'm forming the local trust here. There's some value that I can order by in local trust. And for pre-trust, I chose a different value to rank these seeds by. These values don't have to be the same. It doesn't matter if they're significantly different in terms of if this was decimals like 0.01 and this is in the millions, all values get normalized, which means they get scaled between 0 and 1 per se. And so it doesn't matter like what values you choose for local trust and for pre-trust. They don't mess with each other, and they don't even change how the algorithm really works themselves, right? So that's something to keep in mind. So diving into the Python notebook, if you don't know what a Python notebook is, it's essentially you can run a Python script in segments and add this nice text in between segments instead of it being just like a one-off script. So I'm importing a few packages here: the OpenRank SDK, the Dune SDK, NetworkX, which is what I already covered with these algorithms, and scikit-learn, we're actually not going to really talk about in today's section. But here I'm getting pre-trust and local traf graphs from Dune. In this case, I am just literally pulling the query. I think this is local trust, right? So 3756692, 3756692. I'm just getting the rows here. And then I'm also pulling the seed. And I actually did an extra weighting here where I want to make sure of two things. One, I want to make sure that all of the seeds actually exist in this values graph. So there could be seeds that I've chosen in the pre-trust that haven't transferred tokens for one reason or another. And so I have to ignore those. But I'm going to take the seed, and I actually ended up weighting engagement by the number of people that they've transferred tokens to. So it's like the more well-connected you are and the more engagement you get, that is going to be what I use for a final ranking of the seed. And so why would I go and try and add this extra factor in here? It's because in this case, I want our pre-trust seed nodes to be as well connected as possible. So what does that mean? So I'm using NetworkX here. You can use ChatGPT to literally like just copy paste this into ChatGPT, ask what it's doing. I'm not going to really explain it here. But what's important here is me calculating reachable nodes. So remember I said, I think there were, I don't know, I think I said earlier there were like 60,000 nodes. Oh, 65,000 nodes here. And there's 91,000 connections, which means there's at least 91,000 different value transfers between these nodes. I want to see how high I can get in terms of reachability of these nodes. Because again, a lot of graphs are going to be separated. I just do NetworkX example graph. Hopefully it'll show me what I'm thinking here. Yeah, like you'll usually end up with graphs that kind of look like this, where some of them are very closely connected. In reality, in crypto, a lot of graphs are actually disconnected because they're just like, it could be a Sybil network or something else. So what I want to do is I want to track a number of reachable peers from the 100 pre-trust nodes. So I actually selected the top 100 nodes from my seed, and I essentially recursively go and see from these nodes, how many nodes can I eventually reach? If I chose a person and checked who that person is connected to and who that person's person is connected to, like how many people can I ultimately end up reaching? So with 100 pre-trust nodes selected using this value weighting up here, I can reach, I think it's 12,000 nodes, which is roughly 20% of the network. Again, there's no number here that's perfect. You're pretty much never gonna get 100% just because of the Sybil nature of crypto. If you do see an extremely high number, that'd actually be very impressive, but it might then also be like a very small community. Like if this was only like 1,000 nodes, then yeah, sure, you should probably have a higher connection rate. But if this goes up to like millions and you're still able to maintain 20% roughly connected nodes, like that's pretty good. Right? Like I won't go too deep into it, but like if you look at Sybil analysis of like Layer 0 or a bunch of other airdrops, the percentage of Sybil is normally between 30 to 40%, right? Objectively, if you can even reach 50% in terms of a connected graph, a user graph, that's already a very good number. 20% is what we're working with here. Now we're going to use OpenRank SDK. You can literally just copy and paste this for when you're running it. You don't have to think about, oh, do I have to change anything? Literally just copy and paste this. Just make sure you have IJV and I and V as like column names on these data sets. And now I'm going to run Eigentrust by plugging in my local trust and the top 100 seeds of my pre-trust. I'm also going to save this output under this name, base transfer 50. So Eigentrust, or specifically the OpenRank platform, is going to run this algorithm for my inputs and save the output scores to base transfer 50. So you can see the scores here. It's like 0.074099, et cetera, et cetera. I only showed the top 5 here, but because the connection here was like 12,600 pre-trust nodes connected, my output is around 12,579. That means there's some people here who scored so low they weren't included, but something that you should quickly note is essentially that the coverage ratio here of your OpenRank output is going to basically match whatever your reachable peers was from your input data. And you can use that mentally to gauge things. I know you're probably wondering, oh, what do these values mean? This is something we're still working on communicating better, but essentially this is a normalized output. If you use this for Degen tipping, it's not like this is going to increase over time. This is always going to be a certain range of values distributed across the network. Because again, that's just what normalization means. A lot of this won't make sense if you don't know what normalization means. So do go and search up what does statistical normalization explained. Fairly simple math concept. Oh no, don't look into normal curves. Here, let me max and scalar. This might even be too technical. Why does this have to be? Anyways, you essentially use the minimum and the maximum value and you scale all other values inside so that then is between 0 and 1. I know that's not a great explanation, but just bear with me on that. I also plotted a histogram and you can see that because of my pre-trust, this is actually a fairly normal or log normal distribution versus if pre-trust was 0, like if I had set alpha to be 0 here, then this would be extremely exponential instead. And usually you don't want it to be that exponential because you want to be able to weight everyone's actions in a network. There could be cases where you don't want to weight everyone's actions, but I'm not going to cover that. This gets more advanced. I recommend you look up what grid search means. Essentially, part of machine learning and models is testing a bunch of different inputs and parameters and seeing the differences. I put a very simple one here that plays with different alphas, and alpha is just C, right? It's the weighting between pre-trust and local trust. And I played with different seed sizes to see what is the mean trust value output, what is the coverage ratio percentage. Obviously, as I increase the seed size, the coverage ratio goes up as well, right? You don't want to choose a seed that's the whole size of the network because as you can see, as I increase the seed, the mean trust actually went down. All right, so you're trading off between the distribution of trust, the size of the seed, and a few other factors. Ultimately, now that I have this saved as a graph, I could call this graph, which Eigentrust ID here is just base transfer 50. I can call this graph and I can call the Dune API with a feed query I've put together and get an output of recommended contracts. This is exactly what this OpenRank feed dashboard is, where I've plugged in base transfer 50. I've actually called it in an API. So if you want to see how to get this OpenRank output in Dune, you can actually just copy this line of code here and query the output directly in Dune if you don't want to query it in a notebook for some reason. And I've taken this feed of outputs here and essentially done a trending contracts, trending channels, trending trending ERC20 tokens, as well as trending NFTs across chains, all with this one feed. And again, our main benefit here is that we got to include 12,000 of the 60,000 casters in this weighting instead of just maybe the top 3 to 5 casters basically defining the whole recommendation system. That was a lot of information. Check out the guide for kind of a full walkthrough. Go read through the docs, check out the SDK, and really go and play with this notebook as well as this dashboard. Just go and change things here and there. Change the local trust to be likes and replies versus token transfers. Change the channel instead of base, go use like the Degen channel or something and see if you do actually get different recommendations in like the contracts or tokens. I know this first office hours, we didn't really go too much into ideating on the 3 different feeds, right? We have our research mission where there's three different feeds you should build for: trending mints, the Degen cast tipping, and optimism governance proposals. So you can basically take the notebook that I've built and try and create something for these feeds. We've come up with ideas here of different variables you could use for pre-trust, different actions you can use for local trust. Go and try and build those queries. If you run into different issues, then definitely let us know. We're here to help. You'll want to scope these down when you're playing with it, like scope it to just a base channel or like art blocks minters or whatnot. Otherwise, the data is gonna be really slow to query, and you're also gonna have very expensive API exports from Dune. Go play around. Go enjoy. Have fun. We're here if anyone has questions. We have till the end of July, so there's still like 25 more days to play around.